So, good morning, students, and today's our topic is Azeotrop. Azeotrop, or you can say azeotropic mixture, or you can say constant boiling liquid mixture. So azeotrop or azeotropic mixture or constant boiling liquid mixture. As the name suggests, constant boiling liquid mixture means a mixture of liquids having constant boiling point is azeotrop. So we can define the azeotrop as the liquid mixture. This liquid mixture is of two liquids. Okay, liquid mixture which boils at constant temperature. The liquid mixture which boils at constant temperature and can be distilled unchanged in composition. Is it clear? So, mixture of two liquids which boils at constant temperature without decomposition or without change in composition is called azeotropic mixture or azeotrop or constant boiling liquid mixture. These azeotrops are of two types. Azeotrops are of two types, and this classification of azeotrop, it is based over the deviation from Raoult's law. So on the basis of deviation from Raoult's law, so on this basis azeotrops are of two types. First, it is minimum boiling azeotrop, and second one is maximum boiling azeotrop. तो azeotrop constant boiling liquid mixture है, means mixture of two liquids which boils at constant temperature and can distill out without changing composition. और azeotrops को दो पार्ट में डिवाइड किया गया है, और यहाँ azeotrop दो टाइप के होते हैं, और ये जो क्लासिफिकेशन है it is based over deviation from Raoult's law. One is minimum boiling azeotrop और दूसरा है maximum boiling azeotrop. तो जो what is minimum boiling azeotrop? So this azeotrop means this liquid mixture, this boils at lower temperature, then the boiling point of both the components of mixture. Means if the mixture boils at lower temperature than the boiling point of both the components, then that one is example of minimum boiling azeotrope. On the other hand, if liquid mixture this boils at higher temperature, then boiling point of both the components of mixture, liquid mixture, is called maximum boiling azeotrope. See, entire mixture does not boils at the constant temperature. A certain composition boils. We'll discuss this one in detail. Firstly, liquid minimum boiling azeotrope here. This. Remember, the mixture, or you can say solution of two liquids which exhibits positive deviation, from Raoult's law, forms minimum boiling azeotrope. Means वही मिक्सचर, वही सॉल्यूशन मिनिमम बॉइलिंग एजियोट्रॉप फॉर्म करते हैं जो कि राउल्ट्स लॉ से पॉजिटिव डेविएशन शो करते हैं. नाउ if we will discuss the examples of such solutions, so examples of such solutions are, it is H2O and C2H5OH, or you can take H2O and C3H7OH, propanol. There are other examples also. One is CHCl3 and ethanol, means C2H5OH, etc. So these are the examples of the solutions exhibiting positive deviation and therefore forms minimum boiling azeotrope. We'll explain it by taking an example of mixture of water and ethanol. See, so for the purpose, we'll plot a graph between the boiling point and mole fraction. At one axis, we are taking boiling point, while other axis we are taking mole fraction. At this end, there is C2H5OH, means इस एंड पे C2H5OH की मोल फ्रैक्शन केवल 100% है, और as we proceed in this direction, the mole fraction of C2H5OH is decreasing, or at this end the mole fraction of C2H5OH is 0. While इस point n पर mole fraction of water is 100%, जबकि इस डायरेक्शन में ये continuously decrease होते जा रहे हैं और here the mole fraction of water reaches to 0. Means in this direction mole fraction of water is decreasing, जबकि इस direction में mole fraction of ethanol is decreasing. Now the boiling point of water, you know, it is 373 Kelvin, while the boiling point of ethanol, it is here 351.5 Kelvin. Okay? Now when this mixture of ethanol or water is boiled, तो एक certain composition which contains 4.4% water and 95.6% ethanol. This certain composition, or in terms of mole fraction, the mole fraction of water is 0.056, while mole fraction of C2H5OH is 0.944. This certain composition, this boils at, like here, this composition is lying here. So this composition boils at a temperature, and here the temperature is 351 Kelvin. See, a certain composition of this mixture boils at temperature 351, which is lower than the boiling point of ethanol as well as boiling point of the water. So this one is an example of minimum boiling azeotrope. Is it clear? And this composition which boils together at constant temperature is called azeotropic composition. Remember, this azeotropic composition, this can't be separated by fractional distillation. It means अगर इथेनॉल और वाटर मिक्स हो चुका है तो हम 95.6% इथेनॉल से प्योर इथेनॉल ऑब्टेन नहीं कर सकते हैं. वी कांट सेपरेट 4.4% वाटर, क्योंकि ये पर्टिकुलर ये कंपोजिशन जो है वो एक साथ कांस्टेंट टेम्परेचर 351 केल्विन पर बॉयल हो जाता है. नाउ अब क्वेश्चन उठता है कि क्यों ये पर्टिकुलर कंपोजिशन boils at lower temperature than the boiling point of both the liquids. तो रीजन है, एक्चुअली व्हाट हैपेंस कि सॉल्यूशन जो कि पॉजिटिव डेविएशन शो करते हैं उसमें एक वन इंटरमीडिएट कंपोजिशन, जैसा कि इस केस में 4.4% वाटर एंड 95.6% इथेनॉल इज इंटरमीडिएट कंपोजिशन. तो वन इंटरमीडिएट कंपोजिशन, this have highest vapor pressure and therefore it boils at lower temperature, or you can say boils at lowest temperature. So is it clear? यहाँ पर क्यों ये दो लिक्विड मिक्सचर दो लिक्विड्स का एक सर्टेन कंपोजिशन दोनों के बॉइलिंग पॉइंट से कम टेम्परेचर पे बॉइल होता है? क्यों? क्योंकि इस कंपोजिशन का, ये एक इंटरमीडिएट कंपोजिशन है, का वेपर प्रेशर मैक्सिमम है, और वेपर प्रेशर जब एटमॉस्फेरिक प्रेशर के बराबर हो जाता है तो बॉइल हो जाता है, और इस कारण इसका लोएस्ट टेम्परेचर पे ये बॉइल हो जाता है। इज इट क्लियर? नाउ सी, इस डायग्राम में दो कर्व है। जो अपर कर्व है, दिस अपर कर्व इज फॉर वेपर फेज एंड दिस लोअर कर्व इज फॉर लिक्विड फेज। ऐसे यहां पर अपर कर्व इज फॉर वेपर फेज, लोअर इज फॉर लिक्विड फेज। ठीक है? तो एजियोट्रॉपिक मिक्सचर का वेपर फेज और लिक्विड फेज में जो कंपोजिशन होता है वो सेम होता है, और इसी कारण जो एजियोट्रॉपिक मिक्सचर है वो कांस्टेंट टेम्परेचर पे लाइक प्योर लिक्विड बॉइल होता है। यहां पर हर पॉइंट पर इक्विलिब्रियम होता है। ठीक है? तो एजियोट्रॉपिक मिक्सचर का वेपर फेज और लिक्विड फेज में जो कंपोजिशन होता है वो सेम होता है, इक्वल होता है, एंड दैट्स व्हाई एजियोट्रॉपिक मिक्सचर बॉइल्स at constant temperature without decomposition or without change in composition. Is it clear? Now, after that, we'll explain the maximum boiling azeotropes. So, as we discussed that here the maximum boiling azeotropes जो होते हैं is a liquid mixture which boils at higher temperature than the boiling point of both the liquids. Here remember that the solutions means liquid mixtures which exhibits negative deviation from Raoult's law, they forms maximum boiling azeotrope. तो सॉल्यूशंस जो नेगेटिव डेविएशन शो करते हैं राउल्ट्स लॉ से, दे फॉर्म्स मैक्सिमम बॉइलिंग एजियोट्रॉप. नाउ वी विल डिस्कस सम एग्जांपल्स ऑफ सच टाइप ऑफ सॉल्यूशंस. So examples of such solutions which exhibits the negative deviation are, so one is H2O and HCl, H2O and HI, H2O and HNO3 etc. तो ये जो सॉल्यूशंस हैं, ये जो लिक्विड मिक्सचर हैं, दे शोज नेगेटिव डेविएशन, और इसलिए ये फॉर्म करते हैं मैक्सिमम बॉइलिंग एजियोट्रॉप. अदर एग्जांपल और हो सकता है H2O and HClO4. ऐसे बहुत सारे एग्जांपल हैं. Now we'll explain it by taking example of this solution of H2O and HCl. Here we'll plot a graph again in between the boiling point means temperature and mole fraction. ठीक है? See here at this end, this is the water, mole fraction is 1, और इस डायरेक्शन में क्योंकि आप जानते हैं sum of mole fraction of all the components is 1, तो here it is 1 और यहाँ पर as in this direction the mole fraction of water is decreasing and it reaches to 0. On the other end here the mole fraction of HCl is 100% और इस डायरेक्शन में ये रिड्यूस होते चले जा रहे हैं और it becomes 0. ठीक है? The boiling point of water, it is well known. It is how much? 373 Kelvin. While boiling point of HCl is 188 Kelvin. Now, एक certain composition which contains mole fraction of HCl 0.111 or mole fraction of H2O 0.89889. So this intermediate composition boils at another temperature 381 Kelvin. This intermediate mixture, a composition, boils at the temperature 381, which is higher than the boiling point of both the components. Therefore, is example of maximum boiling azeotrope. And this composition boils at lower temperature at higher temperature than the boiling point of both the liquids. So is an example of maximum boiling azeotrope. And the composition which boils together, this one, is called what? Azeotropic composition. Is it clear? See, again, this azeotropic composition can't be separated by fractional distillation. अगर हमें 100% सेपरेट करना है तो some other methods we must apply. Again, यहाँ पर भी जो upper curve है denotes vapor phase, जबकि ये जो lower curve है denotes liquid phase. Here it is vapor phase, this one is liquid phase. इस azeotropic जो मिक्सचर है इसका कंपोजिशन वेपर फेज और लिक्विड फेज में सेम रहता है. तो azeotropic mixture has same composition in vapor phase and liquid phase, or therefore due to this reason it boils together like a pure liquid. Again यहां पर अगर हम ये डिस्कस करें कि why this mixture boils at higher temperature, तो रीजन सेम है. The solutions which exhibits negative deviation in solution में one intermediate composition, जैसा कि इस केस में this composition is intermediate composition. तो one intermediate composition have lowest vapor pressure and therefore this boils at highest temperature. Is it clear? So why this certain composition boils at higher temperature? Because this intermediate composition is having the lowest vapor pressure and therefore boils at highest boiling point. ठीक है? तो this intermediate composition का ना lowest vapor pressure है और इसलिए ये maximum highest boiling point पर even the temperature is higher than the boiling point of both the components पे boil होता है. ठीक है? और ये एक साथ क्यों boil होते हैं दोनों लिक्विड में एक साथ? तो the reason is कि जो azeotropic mixture है उसका जो वेपर फेज और लिक्विड फेज में जो कंपोजिशन है वो सेम है, और इस कारण ये मिक्सचर होते हुए भी प्योर लिक्विड की तरह एक कांस्टेंट टेम्परेचर पे एक साथ बॉईल होता है।